Yeah, it's working.
Okay, do it again to stop it. Okay, we are going to learn, it's called dimensional analysis. So let's say that. Ready, go.
Dimensional analysis.
Quit talking. Dimensional analysis is one of the most useful things that you will ever learn, because you're going to use it in biology, in chemistry, in math. It can convert or change any measurement into any other measurement. Anything. It's so easy a method you don't even have to think about it. Now, when I was in school, they would give us a problem like this when I was your age, 8th grade, and I had to do a problem like this. They wouldn't tell us, they didn't teach us dimensional analysis. I had to sit there and figure out, okay, do I multiply or divide? And I had to figure out, do I multiply or divide? And I had trouble with that when I was your age. And actually, all through high school, we had to do that without benefit of dimensional analysis. When I finally got to college and they taught us dimensional analysis in chemistry class, I thought back to when I had to do it without it, and I thought, oh my gosh, are you kidding me? This is so easy. All those years I was racking my brain, do I times or divide? Oh my gosh, it was hard to figure out. All that time, if I had known dimensional analysis, I could have just whipped them off. And I actually got mad. Why didn't they teach me this like 4 years ago? So listen carefully, and you will learn something very valuable. The way you do this, whatever number they give you, measurement they give you, 8,500 feet, I have to write that down. So you write down what's given. That's the first step. 8,500 feet. Then you put a time sign and a fraction bar. Time sign, fraction bar. Then whatever label's on the top, you put that label on the bottom. Whatever label's on the top, you put that label on the bottom. Whatever label's on the top, you put that label on the bottom. Now I'm going to say that faster and faster and faster and faster. Whatever label's on the top, you label on the bottom. Whatever's on the top, you label on the bottom. Whatever's on the top, you label on the bottom. If you say it really fast, it sounds like a turkey. So sometimes I call it the turkey step. Whatever label's on the top, you label on the bottom. Whatever label's on the top, you label on the bottom. Whatever label's on the top, you label on the bottom. Then you lick your finger and stick your head and say, where am I going? Did they tell me to go to pounds? No, they said to go to miles. So that's what you put on top, because that's where you're going. You're going to miles, M-I period. Then, the biggest man gets the one. Who's bigger, a mile or a foot?
Mile.
A mile. So that's good. So he gets the one. The biggest man gets the one, because I'm the one. I'm the biggest man. And then you enter the relationship between feet and miles. How many feet are in a mile?
5,280.
Yes! 5,280. Ricky Lake got it.
Oh, you broke it.
That's why I was named Ricky Lake. This on YouTube.
YouTube. Get it? Tube. YouTube! Anyway, now you do something called TTDD. TTDD. That stands for top times down divide. If both of the numbers end up on the top, then you times them. Top times. He's on the top and he ain't, so you don't times him. If one of them's down, which he is, then you divide. Down divide. Top times, down divide. He's down, so that tells me I'm supposed to divide this time. You always punch that number first. Whatever's first, punch it. Now, you have a calculator, Wally World. Would you punch in 8,500, please? Then, since that's on the bottom, it's down, punch divide by 5280 and tell me exactly what your calculator says.
1.689.
1.6 what?
09.
09. And now watch this to get the label. We have a foot on the top and a foot on the bottom. Gone! They cancel each other out. The only label left is
Miles.
And that's what we wanted. So 8,500 feet is the same as 1.609 miles. And that, my friend, is called dimensional analysis. Now we're going to do an example over here. I wanted to be one top and one down. If I make it top, then I'd make this pounds. Pounds to ounces. Okay, the first step, write down what's given. 26, what's the abbreviation for pound?
LBS.
LB, not PD, that's police department. So LB, why in the world would pound be LB? Well, it comes from a Latin word called libra. That was a Latin word for pound, so that's where it came from. All right, after you write down what's given, you put a time sign and a fraction bar. This is the turkey step. Whatever label's on the top, you put that label on the bottom. Whatever label's on the top, label on the bottom. Lick your finger, stick your head and say, where am I going?
Pounds.
Ounces. The abbreviation for ounces is OZ, period. Write it in cursive and write that in cursive, because if you don't write in cursive, watch this. Let's say I write 21 pound. 21 pound. That looks like 211B. So you should write 21, skip a space, pound, cursive. Now, the same thing with OZ ounces. Let's say you write 20 ounces. 20 ounces. That looks like 200Z. 20 ounces, skip a space, OZ cursive. The biggest man gets the one. Who's bigger, a pound or an ounce?
Pound.
Pound. He gets the one because he's the biggest man. He's the one. He the one. He the one. He the man. Now, how many ounces?
16.
Are in pounds?
16.
You enter that relationship. There are 16 ounces in a pound.
Oh.
Top times down divide. Both of these are on the top, so you times them. Wally World, would you punch 26 times 16? See if you can get a
416.
Huh?
416.
416, and then the label we have a pound on the top, a pound on the bottom, gone. The only label left is ounces, so it's 416 ounces. And that, my friend, is what? Dimensional
analysis.
Say that.
Dimensional analysis.
And it's very useful. You can change 3 years into seconds in no time flat just by using dimensional analysis. All right, we're finished. Cut that.